So in this lecture we talk about mapping cone. So say we are given two chain complexes, chain complex A and another chain complex B, and you have a map F which maps chain complex A to chain complex B. So chain complex A looks like this: an plus 1 goes to an to an minus 1 and so on, and you have chain complex B, bn plus 1 going to bn bn minus 1, and you have the maps here. So this map right here is dn, this map is partial n, here it is dn minus 1, here it is partial n minus 1. Similarly here you have dn plus 1 and you have partial n plus 1. So we are going to omit the subscripts here because we know what module this map is acting on, and that will make it clear. So mapping cone of F. So mapping cone of F. So this F is a new chain complex. So this new chain complex you denote as Cn. This is an direct sum with bn plus 1. So you take an here and then you take bn plus 1 from here. So if you have a new chain complex, we have to have a boundary map. So this is our Cn part. So this n index matches n here, and this bn is always n plus 1, and this is going to Cn minus 1. So again this n minus 1 matches n minus 1 here, and this is one more. So between these two we have a boundary map. So let us call this boundary map here as delta. So this is our delta. So this delta acts on A and B. A is here and B is here. So the differential is given like this. So you have minus dA here, and then you multiply this with B, you get minus FA plus delta B. So this is our differential map acting on AB. So AB here, you apply your boundary map which consists of D, F and delta arranged in this manner, and you land up like this. You get minus dA here and you get minus FA plus delta B in the second part here. Now since we are saying this is a differential of our module, delta square should be 0. So you multiply these two matrices, delta times delta, you get delta square. You multiply this, you get D square. This is 0 because this is the differential of this map, and this partial square is 0 because this is differential of this map. Now we have to show this is 0, but this follows from the commutativity of the diagram. So pick up this square for example, and you pick up some element here. So this element, if you first apply D and then F, so first you apply D and then F, you will land up here. So say to this brown element. But you could also go first F and then partial, because the square commutes, you will still land up at the brown element. So first F then partial, first F then partial, you get the same element. So you have the same element df and partial f, so that gives you 0. So we have constructed a new chain complex. So element by element, this is how it will look like. So you have 0 going into an, this goes in like this, and then bn plus 1 goes like this. So you can see this is a short exact sequence, and this is generally written as so cone of f nth part. So this is nothing but cone of f, the nth part. So you arrange these and you get a short exact sequence of complexes. You get complex A, this C complex corresponds to this, and then you write B complex minus 1 to denote that we have n plus 1 here, not Bn. So in general, if you just write B complex, that means we are going from An to Cn to Bn. The Cn is this part. But we are not going to Bn, we are in fact going to Bn plus 1 as denoted by here. So therefore you write minus 1 here. So since you have a short exact sequence of complexes, now you can have the long exact sequence of homology, hk plus 1 this to hkc here, here and here. So just the standard long exact sequence. And the only thing you need to remember is that hn plus 1 of b minus 1 is just hn of b complex. So this is nothing much, it is just shifted by 1. Therefore n plus 1 here of this shift is same as hn of this. So wherever you get k plus 1 this, you don't have to worry about it. You just think of it as a normal complex and compute the homology using this formula. Now this mapping cone is extremely important. This will become the first example of a total complex. So in general, whenever you see these morphism between chain complexes, you can form a mapping cone, and the new complex is written like this. You have A and B. Instead of C, generally it is written as cone of F. So where cone of F essentially means this complex right here. So this cone of F is written so as to understand that this C complex doesn't drop from the heaven. It is just related to F itself, which connects A and B. And you can see this F is inherent part of our differential of our new chain complex. So instead of C bullet, you write cone of F.